Hello. In this video, I'm going to show you a method for finding the solutions to a quadratic. The solutions being the roots or the places where the graph of that function crosses the x-axis. And the method that I'm going to show you does not require factoring, and it does not require the use of the quadratic formula. This particular method was recently discovered by a mathematician named Po-Shen Loh. That's why I'm calling it the Po-Shen Loh Method. He's a mathematician who is working at the Carnegie Mellon University in Pittsburgh. So the interesting thing about studying mathematics is that sometimes, if you're lucky, you will come across an idea that is actually very, very old, and that someone discovered it or someone noticed a pattern, but they didn't know how it could be applied to other things. And in the case of this particular method, that's what happened. Po-Shen Loh was studying various properties of graphs, and he noticed a pattern that actually had been discovered 4,000 years ago, but it hadn't been used in this context before. And really the heart of this process is based on a really simple concept, which is that the shape of a parabola, the shape of the graph, of the curve, is symmetrical, and that there is a line of symmetry that goes straight down the center and it crosses at the vertex, so the minimum in the case of the one that I've drawn here, and that each of the zeros are going to be exactly the same distance to the left and to the right of that value. So looking at that symmetry, this one is going to be some unknown amount to the left of that line of symmetry, and the other one is going to be the same distance to the right of that line of symmetry. And that holds true for any parabola. It could be opening up, opening down. Even if it doesn't have real solutions, it's possible that the entire curve is above the x-axis. But as long as you know where that axis of symmetry is, you can determine where the zeros would be, or the solutions would be. So this technique is very, very efficient for solving all kinds of quadratic equations. Okay, so we're going to start with first example, which is x squared minus 8x plus 12. And that is not the graph that I've drawn above. The graph above was just for illustration purposes of the symmetry. Okay, so the first step in this process is to look at the linear term, the term that is in x as a coefficient and then a single x, and to pick out that coefficient. So we're interested in, this is a b value. We're interested in what is the value of negative b, and in this case, negative b would be 8. The second piece of information that we're going to be using is the 12. So that 12 represents a product. Okay. Now, I'm going to take that negative b and I'm going to divide it by 2. And that's 8 over 2, which is 4. So this value of negative b over 2, or 4 in this case, is representing where that center line or that line of symmetry would be located on the graph. So that's useful information if you were sketching the graph, for example. All right, so now what to do with that? Well, we know that each of the zeros are going to be to the left and to the right of that value of 4. So it's going to be 4 and then some unknown value to the left, and 4 and that value to the right. So you can refer to this sketch here to think of that. So this one would have been 3 and minus u and 3 plus u. Okay. So these two expressions of 4 minus u and 4 plus u represent the locations of those zeros. I don't know what u is yet, but I'm going to get there. So that's where this value of 12 is going to come into play. So I'm going to take the two zeros, the 4 minus u and the 4 plus u, and I'm going to multiply them together as a product. So one of the zeros times the other zero, and that has to be equal to my product, which was 12. So if you're looking at this, you should right away recognize that that's a difference of squares situation. So that works out to 16 minus u squared, and we've still got this 12 over here. With a little bit of algebra, we can rearrange to isolate for the u squared. So I'm going to bring the u squared over to the right, so it's positive. And I'm going to have 16 minus 12, which is 4. So far, so good. And we can solve for u. It's going to be plus or minus square root of 4, which is 2. So my u value in this case is plus or minus 2, which means I can take that back in, little box around that, back into my original two statements here, 4 minus u and 4 plus u, to find the location of the zeros. So 4 minus u, let's say it's positive 2, and the other option is equal to negative 2. So 4 minus 2 is 2, and 4 plus 2 is 6. So the zeros of this quadratic are 2 and 6. Which means that if I were being asked to write it in factored form, I could state x minus 2 and x minus 6 as the factored form of that equation. Okay, we're going to do a second one in the same method. So this one is y equals x squared minus 2x minus 8. So step 1 is find the b, which in this case is negative 2. Determine negative b, which is 2 in this case. Identify the product. That's negative 8. Negative b over 2 is going to be my center line, or my line of symmetry. That's 2 over 2, which is 1. So using the line of symmetry and then going to the left and to the right of that line of symmetry, my two zeros will be located at 1 minus u and 1 plus u. And I'll continue. So difference of squares, 1 minus u, 1 plus u, multiplied together, their product is negative 8. So we've got 1 minus u squared is negative 8. isolate u squared. That's 9, which means that u is plus or minus 3 in this case. So you have a choice. You can take the plus or minus 3 and you can sub it into the 1 minus u statement as I did above, or you can sub it into the 1 plus u. It doesn't make any difference. So I prefer to use the addition one, just because addition is a little bit easier. You're less likely to make a mistake with the positive and negative values. So the two zeros are going to be located at one plus 3 and 1 minus 3. So that's 4 and negative 2. If I was being asked to find the factored form of this quadratic, I could do that very quickly. It's going to be y equals x minus 4, x plus 2. And that is the Po-Shen Loh method. Yeah, I will share in another video a few more examples if you would like to see some where the values are a little more complex, including some decimal values, and one where the coefficient is not 1 for the first term.